Hi folks, today we're going to take a look at where lines cross the X and Y axis. This is a handy skill when we go to sketch straight lines, and we'll do more of that next year. And in fact, it's actually a very important thing when it comes to any sort of straight line, curve, circle, etc. To find where lines and curves cross the X and Y axis, the same conditions always apply. So first of all, what I can say here is that lines cross the x-axis when the y value is equal to 0, and lines cross the y-axis when the x value is equal to 0. Now that should be quite obvious for us, because if you think about the coordinates first of all, so if I look at the x-axis, this would be 1, 2, 3, and so on. Think about what those coordinates actually are. We have 1, 0, 2, 0, 3, 0, and so on. So whenever a line would cross through the x-axis, the y value is always 0. And it's the same when we talk about the y-axis. Okay? Lines cross the y-axis when the x values are 0. So if I just think about where we have the coordinates on the y-axis, we would have 0, 1, we would have 0, 2, we would have 0, 3, and so on. So when lines cross the y-axis, the x value is always 0. Okay? So let's take a look at some examples then. What I've got here is, I want to find the coordinates where the following lines cross the x and y axis. So the first example I've got here is y is equal to 4x plus 2. So I can find where it crosses the x-axis by writing down that very, very simple, straightforward formula, straightforward line we've got here, okay? Lines cross the x-axis when y is equal to 0. Okay, let's write that out. So line crosses the x-axis when y is equal to 0. So let's actually do what that says. Set your y value to 0. So that will give me 0 is equal to 4x plus 2. Then go ahead and solve it. So we get 4x is equal to minus 2. So x has to be minus a half. So this means that this line crosses the x-axis at minus a half, 0. Okay. We can also find where it crosses the y-axis. So I can say line crosses the y-axis when x is equal to 0. So let's set the x value to 0. So y is equal to 4 times 0 plus 2. So y is equal to 2. So that will give me a y-intercept of 0, 2. Now I suppose in this format we would already know that, because it's in the format of y is equal to mx plus c. So if we have the 2 as the c value, that is the y-intercept. So the y-intercept is definitely 0, 2. Okay, that's all we do. So to find where it crosses the x-axis, we set y to 0 and then solve. To find where it crosses the y-axis, we set x to 0 and then solve. Let's look at the next example. Excuse me. So, what we have here is another straight line equation. It's not in the same format as before, so we can't easily read off the y-intercept, but it's still a straight line equation, just in a different format. So, let's find where it crosses the x-axis. So we'll write out our sentence that says, line crosses the x-axis when y is equal to 0. So let's set y to 0. So we get 8x minus 5 times 0 plus 3 is equal to 0. So that will be 8x plus 3 is equal to 0. Solve this. So I get 8x is equal to minus 3. So x has to be minus 3 over 8. So that means that it's going to cross the x-axis at the coordinate minus 3/8, 0. And I can then go and find where it crosses the y-axis, so we write that out. So line crosses the y-axis when x is equal to 0. So let's do that. So we have 8x minus, oh, my mistake. We have 8 times 0 minus 5y plus 3 is equal to 0. So that would give me minus 5y plus 3 is equal to 0. So minus 5y is equal to minus 3. So y has to be 3/5. And that will give me a y-intercept of 0, 3/5. Okay. What we'll also do here is we'll look at more of this example that we have here just at the end. This 8x minus 5y plus 3. Because this, as I said, this is still a straight line equation, but it's not in the format that we're used to. So let's look at more of this type just now. So what I've got here is, in this example, if I want to read off the gradient and the y-intercept, what I have to do is I have to change the subject of the formula to make it say y equals. Now, we've already spoke about that before. So basically all we do is we just rearrange the formula so that it says y equals. Okay? So, if the first thing I've got here is I want to find the gradient and y-intercept of this line. 3x plus 4y plus 10 is equal to 0. So, what I want to do is make it say y is equal to some gradient times x plus or minus some other number. Okay? So, try and get y on its own. The 3x we need over on the right-hand side. And the 10 we also need over on the right-hand side. So let's move that. So that'll be 4y is equal to minus 3x, take away 10. Remember, change side, change sign. Then I want to divide everything by 4. So that'll give me y is equal to minus 3/4 x minus 10/4. Let's simplify our fraction there. So I get y is equal to minus 3/4 x minus 5/2. You must always simplify your fractions. So only when your equation is in this format of y is equal to some gradient times x plus c, even though we've got a minus there, only then can you read off what the gradient is and what the y-intercept is. So this means that the gradient is going to be minus 3/4 and the y-intercept is going to be minus 5/2. Okay? So it's easy enough when you've got the equation in the format. When it's not, you have to put it into the format of y is equal to mx plus c. Let's look at example B then. So we have minus 5x plus 2y is equal to 3. So I want my equation into the format of y is equal to mx plus c. Okay? So let's try and get y on its own then. So what doesn't belong there? Well, the 3 is already on the right-hand side, so I'm going to take the minus 5x across to the right-hand side to join it. So that will give me 2y is equal to 5x plus 3. So therefore, y is equal to 5/2 x, divide everything by 2, plus 3/2. So that will tell me that It's in the format now of y is equal to some gradient x plus some value. So therefore the gradient is going to be 5/2 and the y-intercept is going to be 3/2, 3/2. And we're always fine to leave numbers as fractions as long as the fractions are simplified. Okay? Last example, we'll take a look at this. Okay, just another random equation. Let's make the subject say y equals mx, y is equal to, and then we'll have the mx plus c. So I want it in the format of y is equal to mx plus c. So let's do that then. So let's think, what doesn't belong there? Well, the -7 needs to move across, and the 18x also needs to move across. So let's move those two things across then. So that'll leave me with -4y is equal to -18x plus 7. Do not forget, change side, change sign. Then we're going to divide everything here by this -4 value. Okay, because it has to be positive y equals on the left-hand side. So I get y is equal to -18 over -4 x plus 7 over -4. Now we need to tidy things up a wee bit here. So we've got y is equal to minus divided by minus is a positive. So it gives me 18/4 x, and I've got a plus minus here. So that's going to give me an overall negative 7/4. Okay? All I need to do now is just tidy up this gradient. So that'll give me y is equal to simplify 18/4, divide top and bottom by 2. So I'm going to get 9/2 x minus 7/4. And now I can read off my gradient and y-intercept, because it is indeed in the format of y is equal to mx plus c. So I can say that the gradient is equal to 9/2, and the y-intercept is equal to -7/4. And that's all we do. That is how we find the gradient and y-intercept of a line when it's not in the usual format of y equals mx plus c. We need to change it into that format and then just read it off. Okay? What I'm going to get you to do now is I'm going to get you to pause the video and try questions 11 and 12. Question 11, you're going to find where these equations here cross the x and y axis. And then question 12 is going to be this idea of just finding the gradient and y-intercept. So you have to write it in the format of y is equal to mx plus c. So for question 12, write it in that format. For question 11, set the x value to 0 to find where it cuts the y-axis, and set the y value to 0 to find where it cuts the x-axis. Please now pause the video so that you can do those questions. And here's the answers for those questions there. Hope you all got on okay.